lesson, we are going to look at horizontal projection and projection at an angle. In the previous lesson, we looked at a body projected along the vertical. We looked at a body projected downwards, and that under free fall. So today we are going to look at something different. So by the end of this lesson, you should be able to sketch a distance time graph for a body projected horizontally. You should be able to calculate the horizontal displacement, the instantaneous speed, the time taken for a body projected horizontally to move through a horizontal displacement or a vertical displacement. We shall look at calculating the instantaneous velocity of the body. We shall also look at a body projected at an angle, actually which brings in the element of projectiles, and also shall look at the related terms, i.e. the definition of a projectile, the angle of projection, the trajectory, the range, and the time of flight. We shall also derive the various expressions for maximum height covered by the body, the vertical displacement, the equation of trajectory, and also the instantaneous velocity. And we shall wind it all trying out several calculations. At horizontal projection. So a body is said to be projected horizontally. A body is projected horizontally if it's given an initial velocity along the horizontal and left to move under the influence of its weight only, under the influence of its weight only. Now, so we shall be using a particle to represent a given body. So if this body is given an initial velocity u, this body will not continue moving along that straight line because of the acceleration to gravity. So as this body moves, it will describe a parabolic path. So it will be attracted downwards due to the gravitational force. Now if we take this to be the starting point, and at a time t, if this body is at point P, then the state of this body, we shall be looking at its velocity v, its displacement from the horizontal and vertical, and also we are going to look at the time t taken. So in this case, if we draw a tangent at this point, the tangent will represent the direction of its velocity, and if we draw our convention set of axes, then this velocity v will have a component which I'm going to denote Vx along the horizontal, and also a component which I'm going to denote Vy along the vertical. So in this case, the x will be the horizontal displacement, and the y is going to be the vertical displacement. In order to determine the relation between these quantities, we shall be again using the equations of uniformly accelerated motion. However, we shall have to split this motion into two. We shall split it into vertical motion, and we shall also split it into the horizontal motion. What you have to note here, the motion along the horizontal, we've got no acceleration, and therefore the speed, the horizontal component Vx, will remain the same as u, i.e. the body does not accelerate along the horizontal. However, when it comes to the vertical motion, the body will be accelerating along the vertical with the acceleration g, that is the acceleration to gravity. So in this case, we are going to write down the equations that will help us to determine the various values for the state of the body. So considering horizontal motion, so for horizontal motion, from S is equal to ut plus a half gt squared. So that is the general equation for a body which is uniformly accelerated. So to show that I'm dealing with the horizontal, I'm going to put this in subscript. So in this case, the Sx, so if the body started from point O and is at point P, so we shall have our Sx now, which is x, will be equal to the Ux. So in this case, the Ux is the initial. Since the body is not accelerating, we are going to put g equals 0. So x will be equal to ut, and that is going to be our equation 1. So for horizontal motion, there is no acceleration. G is equal to 0. Then for vertical motion, for motion along the vertical, so from V is equal to U plus 18. When we put A as a G, that's the equation which we shall get. So we are now going to have V Y will be equal to Uy plus GT, where Vy and Uy are the vertical components of the velocity of the body at a given time. So in this case, Uy is the component when t is equal to 0. Uy is the component of the velocity when t is equal to 0. Now, in this case, the Uy is going to be a 0. Therefore, we shall have the Vy at any time t is calculated from g t, so you can call that equation 2. So also from S is equal to ut plus a half gt squared. So Sy will be equal to Uy plus that. So So if I want to find the value of y, the vertical displacement, so I'm going to take my y positive, since I have also used the value of g as a positive. So we shall be having our y is equal to, now the uy, that is the component which is 0 at t equals 0. Therefore the whole of this will reduce to 0, and we shall have a half g t squared. So our y will be equal to a half d t squared. Then b at t equals 0. At t equals 0, our uy is equal to 0. So we can call this our third equation. So if you were asked to determine or to find the instantaneous velocity, then in this case you will do exploit the Pythagoras theorem. So with the Vx and Vy known, the instantaneous velocity, V is given by the square root of Vx squared plus Vy squared, making an angle theta given by tan inverse bracket Vy divided by Vx. So basically that gives us the relationship between the quantities that define the state of the particle or of the given body after projection. So we are now going to try out numerical examples so that they can help us to understand more what we have just put down. So is projected horizontally at 20 meters per second from a point 78.4 meters above a horizontal surface. Find the time taken for the particle to reach the surface and the horizontal distance traveled in that time. So in this case, the question requires us to find the time taken for the particle to reach the surface and the horizontal distance traveled. Let me call it x. So let's sketch. So if this is our particle, if it is projected horizontally, so that is the initial velocity u is equal to 20 meters per second. So a point 78.4 meters above the horizontal surface. So if this is our horizontal surface, then this distance here, which I'm going to call y, is given as 78.4 meters. 78.4 meters. So this particle will describe a parabolic path, and it will hit the horizontal surface at that point. So they want us to find the time taken and the horizontal displacement. So we're going to find this distance here, which is x, and also the time taken at this point, and call it t. So in order to determine x, so for vertical motion, considering vertical motion, so from S is equal to ut plus a half gt squared. So now my S is going to be the y. So we shall have our y, which is 78.4. So the initial along with the vertical is 0. So plus a half times g 9.81 t squared. So we are now having the task of making it the subject. So we shall have 78.4 times 2 divided by 9.81 is equal to our t squared. So when we simplify, we shall get 78.4 times 2 divided by 9.81, 15.98. And therefore our t is the square root of 15.98, which is equal to 3.998 seconds. So that will be the time taken by this body to move from this point at an altitude of 78.4 meters onto the surface. So that is our first part for calculating the time. Then the horizontal displacement for horizontal motion. So for horizontal motion, so we shall have our x is equal to ut, where t is now the time taken to cover this horizontal displacement. Therefore x will equal to u is given as 20 times the time which we got, 3.998. So we shall get our x as 79.96 meters. That will be the horizontal displacement. Two vertical towers stand on a horizontal ground and are of heights 40 meters and 30 meters. A ball is thrown horizontally from the top of the higher tower with a speed of 24.5 meters per second and just clears the smaller tower. Find the distance, part A, between the two towers, part B, between the smaller tower and the point on the ground where the ball first lands. So you have to first read through the question, interpret it, and then come up with a simple sketch that will help you to solve for what is being asked. So we are having. After reading through the question, you should be able to come up with a proper sketch, and that is what is shown in the figure. Now looking at that figure, our major aim is going to be finding the relationship between the horizontal displacement and the vertical displacement. So for vertical motion, h equals a half gt squared. For horizontal motion, x equals ut. When you combine the two equations, you come up with a general equation that will enable you to calculate the horizontal displacement. Therefore, x1 gives 34.982 meters, and that is the answer for the first question. Roman 2, the difference between the two horizontal displacements will give us the answer, and that is 34.982 meters. When a particle or a body is projected at an angle above the horizontal, the body will describe what we call a parabolic path. So if this is my ground and I happen to have my convention set of axes, when a body is projected at an angle theta, so this body will describe a parabolic path. And actually another term which we shall be giving to such a motion as a result of a body projected at an angle above the horizontal and left to move freely under gravity, we shall be calling it projectile motion. And the body which is involved in that case would be a projectile. So an example of a projectile, it can be a ball which is kicked. So that ball would describe a parabolic path, or a bomb which is dropped from a body which is moving at a given angle. Now, there are some terms which are related to projectile motion. So we shall be describing them as we proceed. Now, if this is our body, and we take this to be the point of projection, so after some time t, this body will reach a certain point which I'm going to call P, which is at a vertical displacement. So I'm going to call this Y, and it will also have moved through a horizontal displacement which we are going to call X. The instantaneous velocity at this instant, if I call it V, again this V shall be having components. So it shall be having a component along the horizontal which remains the same as that at this instant, and also shall be having a component along the vertical. Now what is important is you being able to resolve the velocity. So at this instant, if the body is projected with the speed u, we shall have a component along this. So the component along the vertical is given by u sine theta, and that along the horizontal is given by u cos theta. So when the body reaches at this point, so the component along the horizontal will remain the same throughout the motion of the body. However, the vertical component will change with the time, which I'm going to call Vy. So the state of the body at a given time t, if I'm to define it using its speed displacement, can also be related using the equations of motion. However, we shall be splitting the vertical and the horizontal motion. Moves, it will reach a certain point and may be interested in calculating the maximum vertical displacement, and we shall also be able to calculate the time taken to attain that maximum height. So let's look at some of the terminologies related. Terminologies related projectile motion. Motion. So the first term which we are going to look at is going to be the angle of projection. Angle of projection. So we shall be defining this as the angle, the velocity vector of projection, the velocity vector of projection mixed with the horizontal. horizontal. So if a body is projected at that point with the initial velocity u, then the angle of projection is the angle this velocity vector makes with the horizontal. So another important term which we shall look at is going to be the trajectory. Trajectory, so it's defined as it's the path followed or described by a projectile. So the path is parabolic, so we shall be calling this the trajectory. Another important term which we need to know is the time of flight. Time of flight. So it's the time taken for a projectile to move from the point of projection to the point hit by the body or by the projectile on a horizontal plane. Passing through the point of projection. Passing through the point of projection. Another term which is important, that is what we shall be calling the range. And it's defined as it's the horizontal displacement from the point of projection to the point hit by the projectile on the horizontal plane through point of the point of projection. Is projected with speed u at an angle theta above the horizontal. Roman 1, find the expression for maximum height hm attained by the body. Roman 2, time taken to reach maximum height. Roman 3, expression for range. Roman 4, equation for trajectory. Now, when you read through this question, you will observe some you need to know, and good enough we have defined them. For example, what they mean, or what is meant by range, or what is meant by trajectory. So we begin by sketching. You are going to sketch the motion of the given body. So if this is our body projected with initial speed u, so this body will describe parabolic path. Roman 1 requires us to calculate the time taken. Roman 1 requires us to find the expression for the maximum height hm attained by the body. So in this case, if this is the maximum point, then the height is that vertical displacement required. So if it is projected with the initial speed u making an angle theta, so we shall break this into its components. So we have the horizontal given by u cos theta, the vertical is given by u sin theta. Now when the body has reached this point, it will be moving horizontally, meaning that the vertical component will be 0. Now we have to think of an equation that is going to exploit the height and also the velocity, and that is going to be the third equation. So from v squared is equal to u squared minus twice g h. So for maximum height, we are considering now the vertical motion. So for vertical motion, we shall have our vy squared is equal to uy squared minus twice g h. So for h max, for h m, we shall have vy must be equal to 0. Therefore, 0 will be equal to our initial component along the vertical, which is u sin theta, u sin theta squared minus twice. So where there is h, I'm going to put that subscript and indicate that we are looking for the maximum height. So when you make it the subject, you get your hm is equal to u squared sin squared theta divided by 2g. That would be the expression for maximum height attained by the body. Tm be the time. So we now have to think of an equation that will enable us to calculate the time. So using the first equation, so from v is equal to u plus, since it's now projected along, so we are going to use a minus gt. So for vertical motion, shall have vy is equal to uy minus gt. Now when vy is equal to 0, then this t will be equal to tm. So putting vy as a 0, that's the condition. Our uy, remember, is the vertical component, which is u sin theta minus g tm. So making tm the subject, shall get tm is equal to u sin theta divided by g. So that is the expression for the time taken to reach maximum height. Roman 3, expression for range. Roman. So remember, range, if we are to use our sketch, if this is our parabolic part, so this is going to be the range. So if our body is projected at an angle theta, so we shall have our horizontal component of u, which is u cos theta, and the vertical component is given by u sin theta. So if the time taken to move from here up to there, if the time is tf, then considering horizontal motion, so for horizontal motion, the range r will equal to, you use the horizontal component, u cos theta times the time taken to move from here up to there, which I have called tf. So that can be equation 1. Now to get the value of tf, so finding tf, that is the time of flight. So from s is equal to ut minus a half gt squared. Now when the body has moved from here to this point, then the vertical displacement will be 0. So for vertical motion, so when s is equal to 0, then this time t is going to be our time of flight, which I have called tf. So substituting, you shall get 0 is equal to, so you use the component along the vertical, which is now u sin theta, tf minus a half g tf squared. So when we try to make tf the subject, so u sin theta minus g tf divided by 2 equals 0. Actually, that is a quadratic equation out of 2. So either tf is equal to 0 or u sin theta minus g tf out of 2 is equal to 0. And when you try to make tf the subject, you will get tf is equal to twice u sin theta divided by g. Now these two values of tf equals 0 is at this instant when the body is at, is the instant when the body has just hit the horizontal plane passing through the point of projection. Actually, by symmetry, you will observe that tf is twice tm. So by symmetry, the time taken by this body to move from here to this point is again the same time it takes to move from here to there. So there is that bit of symmetry. That is why tf is twice tm. Now to get the expression for range, we are going to substitute the value of tf. So if I am eliminating tf from Roman 1 and 2, so we shall get our range r, which is equal to u cos theta times t. Now my t is 2u sin theta divided by g, or you can write this as 2u squared cos theta sin theta divided by G, which is also the same as U squared sine 2 theta. However, this expression requires you to have some knowledge in trigonometry. This can also be equal to that on level ground, such that its initial velocity is 56 meters per second at an angle of 30 degrees above the horizontal. Find Roman 1, the time taken for the particle to reach its maximum height. Roman 2, the maximum height. Roman 3, the time of flight. Roman 4, the horizontal range of the particle. Now, in case you are given this question, you don't have to cram the formula for calculating the maximum height, the time of flight. You always work from first principles. So in this case, so this is our horizontal plane, the initial, the angle theta. So in this case, U is equal to the initial speed, which is 56 meters per second. Theta is given as 30 degrees. So Roman 1 requires us to find the time taken for the particle to reach its maximum height. So let T m be the time taken to reach maximum height. To reach maximum height. So you think of an equation that at least will exploit the given values. So in this case, I'm going to use my first equation. So from V is equal to U minus GT. So for motion along the vertical, I can put that to represent that I'm now dealing with the motion along the vertical. So for maximum height, that is, so when Vy is equal to 0, that's the condition for that time to be that of the maximum height. So by substituting, so we shall have therefore 0 is equal to, now Uy is my component of this speed along the vertical at t equals 0, which is U sine theta. Remember, when you break that into its components. So in this case, where there is Uy, I'm going to put U sine theta minus G Tm. So when I try to make Tm the subject, we shall get U sine theta, substituting the values. So my U is 56, my theta is 30 divided by 90.81. So when you simplify that, you will get your Tm plus 2.85 seconds. So that is Roman 1. Roman 2, the maximum height. The maximum height. So from V squared equals U squared minus 5G H. When Vy is equal to 0, then H is going to be our Hm. So by putting 0, remember your Uy is U sine theta minus 2G Hm. So my HM is equal to U sine squared theta divided by 2G. So here now substitute the values. The U is the 56 squared sine squared 30 divided by 2, 9.81. So we shall get our 56 squared bracket sine 30 divided by 2.96 meters. So you have to make sure that you use the value of G that is given. For my case, I will be using G as 9.81. So that is our maximum height attained by this body when it has reached that point. Represent the time of flight. So from S equals minus a half GT squared. When S equals 0, then that T is the time of flight. So when you substitute, this is U sine theta TF minus a half G TF squared. And when you try to make TF the subject, you will get twice U sine theta. Substitute the values, you will get 2 times U, which is 56 sine 30 divided by G 9.81. Simplify that. .7 seconds. So the time it takes for the projectile in the air is 5.7 seconds. For the horizontal range, which I'm calling R. So R is equal to U cos theta TF, where TF is the time of flight. So when you substitute, your U is 56 cos times my TF, which is 5.7. So if 5.7 is wrong, definitely that it will also make the range to be wrong. So you have to be sober finding the value of TF. So 56 cos 276.4 meters. That will be the horizontal displacement for the body projected at that speed of 56 meters per second at an angle of 30 degrees above the horizontal. A vertical cliff with a velocity of 50 meters per second at an angle of 16 degrees above the horizontal. The stone strikes the ground at a point 240 meters from the foot of the cliff. Calculate Roman 1, time taken by the stone in the air. Roman 2, the height of the cliff. Roman 3, the speed with which the stone hits the ground. So challenge. Remember always time is on your neck. So if this is my, if that's the convention. So we are having our speed u. This arrow is theta. U is given as 10 meters per second. Theta is given as 16 degrees. They have also given us this horizontal displacement x is equal to 240 meters. Now considering horizontal motion, so you split this, find the horizontal component is u cos theta, the vertical is u sin theta. So x will equal to u cos theta t, and call it maybe t1, where t1 is the time taken to move from this point of projection, the point where it hits the ground. Substituting the values, 240 will equal to u, which is 50. My theta is 16 times t1. So make t1 the subject, you get 240 divided by 50 cos 16 degrees. So using your calculator, it will give you 240 divided by 50 cos 16, 4.99 seconds. So that is the time taken. Roman 2, the height of the cliff. So let h be the height of the cliff. U t minus a half gt squared. So h will equal to, now my u is u sin theta, vertical motion, minus a half g t1 squared. So you get your h. So u is 50. This is sin 16 times t1, which is 4.99, half times 9.81 times 4.99 squared. You get your h as 50 sin 16 times 4.99. This is 68.77 minus bracket so this is 122.13. Now when you substitute, you get negative 53.36. Now the instance or the impact of this negative is an indicator that h is below the point of projection. So if h turned out to be positive, then it would mean that that h would be measured above the point or above the horizontal plane from the point of projection. So you don't have to worry once you get the negative value, provided we used this as our negative acceleration. So Roman 3, the speed with which the stone hits the ground. So the speed, that's going to be the with which So in this case, if this is my point and the speed is v, so I'm going to find, so this one remains the same, so it's only the vy which changes. Then I will find this using the resultant of the two components, with which the stone hits the ground. So that v will be equal to the square root of vx squared plus vy squared. So this expression is demanding the values of vx and vy. So vx remains the same, it's the same as u cos theta. So my vy will be equal to, so in this case, you consider the vertical motion, u, v equals u plus ft, so now minus g t1, where t1 is the time taken. So from this equation, when you substitute, u is 50 sine theta, so my theta is 16 minus 9.81 times t1 is 4.99. So you get your vy 50 sine 16 minus 9.81 times 4.99 negative 35.17. The negative means that the component is in the negative direction as indicated on the figure. So my vx is u cos theta, my u, or our u is the 50. Cos theta is 16. So this will give you 50 cos 16. It is positive 48 as suggested by the diagram. Therefore, our v is the square root of 48.06 squared plus, so you can even drop the negative, 35.17 squared. This will give us 2 bracket so it will hit at with that speed 59.55 with a point of projection after moving a horizontal distance d. In the trajectory, it attains a maximum height b. Find, Roman 1, the horizontal and vertical components of velocity of projection in terms of d and b. Roman 2, show that when a body has moved a horizontal distance x, it has attained a height equal to 4bx bracket d minus x divided by b squared. Now, in mechanics, if you want to prove that you have really understood a given chapter, you can always look for proof questions. An example of a proof question is now what we are having here. Questions require you to be well organized. You have to first read the question and understand it properly, then come up with a proper sketch that will help you to get the correct answer. So let's try to sketch first what is given in the question. A particle projected from a point meets the horizontal plane. So taking this as our horizontal plane, so taking this as the point of projection, if the particle is projected with the initial speed call it U. It will move and will describe the parabolic path. So from the question, we've been told that it moves a horizontal distance D. The distance from here up to this point, which is actually the range, is given as D, and on its way it attains a maximum height B. So we are having a maximum height B. Phi Roman 1, the horizontal and vertical components. So we are going to let the vertical component be represented by Uy, and let the horizontal component be represented by Ux. We are now having a task of finding the value of Uy and Ux in terms of the given values B and B. So we are going to consider the vertical motion. Considering vertical motion, so I'm going to use this condition for maximum height. So for the body to attain maximum height, its velocity, its component of the velocity along the vertical will be equal to 0. So using the third equation, so from V is equal to U squared minus pi C GS. So for vertical motion, we shall have our V1 is equal to Uy squared minus pi C G. I can put here a Y as a value to show that I'm dealing with the motion along the vertical. Now when Vy is equal to 0, then my Uy in this case is going to be equal to the maximum height, which is a B. So substituting these values in our mother equation, we are going to have 0 is equal to Uy squared minus 2Gb. Remember, we are looking for the vertical component, which is Uy. So Uy in this case is equal to square root of pi CGB, and that would be the answer for the vertical component. Now let's try to look for the horizontal component. So for the horizontal component, I'm going to consider the horizontal motion. Considering horizontal motion, so we shall have Ux times Tf, where Tf is the time taken to move from here to that point. The time of flight must be equal to D. So this equation here is demanding to get the value of Tf. So from S is equal to Ut minus a half Gt squared. So considering vertical motion, when S is equal to 0, so this U is the Uy, then the T will be equal to the time of flight which I'm looking for. Therefore, when you substitute, you will get 0 is equal to Uy Tf minus a half G Tf squared. And when you try to make Tf the subject, you will get your Tf being equal to twice Uy divided by a G when you make Tf the subject. So this is actually a quadratic equation in TF, and it will give us two values of TF. But for this purpose, I'm interested in this 2uy divided by g, which I'm going to substitute. So TF from equation 1 and 2. So this will give ux times TF, which is 2uy out of g, equal to a d. Remember, I'm now interested in ux. So since already I have the value of uy in terms of b, so we shall have our ux is equal to g d divided by 2uy. So my uy is root of 2gb. So I can even simplify this further. So this is the same as having ux is equal to gd divided by square root of, when this 2 enters the square root, you square it, then 4 times 2, you will get 80 gb. Or you can have ux is equal to the square root, so this one would be g squared divided by 80 gb. So this will cancel with one of that, which can also be the same as square root of g squared divided by 80b. So our horizontal component ux equal to what we have got here, square root g squared divided by 8b. So we are through actually with Roman total distance x. It has attained a height equal to this expression. So our ux is equal to square root of g squared divided by 8b. Now, if our particle has reached a point P whose coordinates are given as x, y, this means that here it will be x and this will be y. They want us to prove. Now, for horizontal motion, so if the time taken is t1, so we shall have our ux times t1 is equal to x, or t1, the time taken, is equal to x divided by ux. So for vertical motion, we shall be having y is equal to uy t1 minus a half g t1 squared. So when we substitute the values of y, we get y is equal to, now our uy is root 2gb, our t1 times x over ux. So my ux is square root of g squared divided by 8b minus g t1 squared. So t1 is x over ux. So my ux, there is no harm, it is square root of g this squared divided by 8b, the whole of it squared. So now I'm going to simplify the given expression to see whether it will reduce to what we are looking for. Now the rest is actually algebra. So this is root 2gb, this is x. So we are going to get y is equal to the square root 2gb times the square root 8b divided by g this squared times x minus half g into x squared over g this squared divided by 8b. So when you simplify this, you get y is equal to the square root. So 2gb times 8, you get 16gb squared divided by g this squared, is that x, minus g out of 2. So this is the same, the 8b will go up, you will get x squared times 8b divided by g this squared is equal to, so this g will cancel with that g, so you are getting 16b squared, and this is now a perfect square. So when you remove the square root sign, you will get 4b divided by d x minus, so this g will cancel with that g by 2 1 4. So 4bx squared, 4bx squared divided by this squared. So when you try to write this under the same denominator, we shall get this squared equals into, so 4bx minus 4bx squared. So I'm going to factorize out common term, which is 4bx. So we shall get 4bx bracket d minus x divided by this squared. When we compare the expression with what was given, we shall have finally proved it. So that will be the answer for that part. Actually, which is a proof, and that's how it goes. A ball is projected so as just to clear two walls, the first of height a at a distance b from the point of projection, and the second of height b at a distance a from the point of projection. Show that the range in a horizontal plane is a squared plus ab plus b squared over a plus b. This represents the horizontal plane. We have our convention. So this body starts in now when they say that just to clear two walls, It means that this height here is, so if these are our two walls of height A at a distance B. So we are having height A at distance B, and we also have height B at a distance A. Height B at distance A. Show that the range on the horizontal plane, so in this case the range is going to be our maximum horizontal displacement along the horizontal plane, which is R. So that is the only information that has been given, which we must play around with to see that we prove or we show the given expression. Now, so we are going to assume if our body was projected with the speed u, and we have the components along with the vertical and horizontal, so I'm going to call this my uy, and I'm going to let this to be my ux. So at this instant, when the body, so we should have along with the horizontal, so this is BA, and at this point we shall have our A, B. So I'm going to call this point A, I'm going to call this point B. So in order to calculate the range R for horizontal motion, so the range R is equal to u x times the time of flight, which is TF. So I'm going to call this, let it be my first equation. So this equation is now demanding the value of TF. So from S is equal to ut minus half gt squared. Now if we are to consider the vertical displacement, we shall say Sy is equal to uy. Now if I want to get my Tf, so when Sy is equal to 0, this T must be equal to Tf. Therefore 0 will equal to uy Tf minus a half g Tf squared. And when you try to make Tf the subject, you will get your Tf is equal to twice uy divided by g. Therefore, my range R is equal to ux times the Tf, which is 2 uy divided by g. So R is actually equal to twice ux uy divided by g. So I can call this my second equation. However, we don't know the values of ux and uy. Therefore, we have to find a way of writing them in terms of the given values of A and B. So I'm going to start at this instant when the particle or when the body is at point A. So for the body, at point A, so again we are going to split this into two, for the vertical motion and horizontal motion. So for horizontal motion, if it has taken a time, which is t call it TA. We shall have our ux GA is equal to the horizontal displacement, which is B. So for vertical motion, we shall have our A being equal to U Y TA minus a half G TA squared. So I'm going to combine these two to eliminate the TA. Y, so where there is TA, we are having B ux minus a half G T. So where there is TA, let's put our B out of ux, the whole of this squared. So we shall have our, so when we try to simplify this, it's giving us A. I'm going to multiply this by ux squared. So we shall get A ux squared is equal to uy ux b minus a half g b squared. You can even multiply by 2, or 2a ux squared is equal to twice uy uxb minus g b squared. So for the body at point A, I'm going to deduce it from this expression. For body at point B, so where there is B, I'm going to put an A. Where there is A, we are going to put a B. So we shall have 2b ux squared is equal to twice uy ux, so this is now an A, minus g, where there is B, we put gs squared. So these are now our two equations. Now we are having a task of making uy ux the subject. However, we are also having this ux squared. So what I'm going to do now, if I'm to eliminate this ux squared, I'm going to make sure that the coefficient on these two equations are the same. So I'm going to multiply this equation here by b, and I'm also going to multiply this equation here by an a. So if this is equation 3, then let this be equation 4. So from equation 3 to uy ux, we are having a b cubed minus b cubed. So from equation 4, when you multiply by a, again we get 2ab ux squared is equal to 2uy ux squared so there are ones. So this is b squared, not b cubed. So this is a squared minus ga cubed. So now we can equate these two and we make this uy ux the subject. Since these are the same when we subtract or when we equate, So we shall have x b squared minus g is equal to uy ux a squared minus g a cubed. So I'm bringing this and I'm taking the other on the other side. So we shall have our uy ux into, is that 2b squared, so it becomes a minus a squared is equal to, so this one is a g now, into b cubed minus a cubed. So our uy ux is equal to, going to make uy ux is equal to g bracket b cubed minus a cubed divided by 2 bracket b squared minus a squared. Now from b minus a cubed is equal to b cubed minus 3b squared a let's first put a plus so that we don't make, so this plus 3b a squared plus a cubed, so we can deduce what b minus a is. So b minus a cubed is equal to, remember it's now negative a which is cubed, so it will make this negative minus 3b squared a, so this one will remain a positive, and now this one will be negative. So that statement is important. It's going to, so uy divided by g, so some space, minus a cubed is equal to bracket b, when it crosses the equal sign, so we shall have plus 3ba into b minus a. So I'm making b cubed minus a cubed the subject, so it gives us b minus a cubed, so this becomes a plus 3b squared, and I have now even factorized. So therefore uy ux is equal to g, so where there is b cubed, we are having b minus a to the power 3 plus 3ba b minus a over 2, so this is now a difference of 2 squares, b plus a into b minus a. When you simplify that, I'm going to factorize out to b minus a. So we shall have g into b minus a squared plus 3ba bracket. So put this in a bracket, and this is the, so that is outside the bracket. This one is like that. So b minus a bracket b minus a over 2 into b plus a b minus a. So this one vanishes with that, and therefore we shall be having now so let me get where to write. ux being equal to, so g bracket, so b minus b squared minus twice ba plus a squared plus 3ba over 2 into b plus a. When you simplify, you get your ux equal to g into b squared plus ba plus a squared over 2 into b plus a. Now from our expression of range, r is equal to 2 out of g into this product, which is g b squared plus ba over 2 into b plus a. So the g will cancel, the 2 will cancel, and remain with our range r equal to, so I can even rearrange this as a squared plus ab plus b squared over a plus b, and this is actually the required expression. So there is some bit of algebra, but provided the equations are correct, you will always arrive to the final answer.